In this video, we're going to be working once again in lesson 4.8, attempting problems example 3E and example 3F. Now, before I really get rolling, I want to make sure that I bring to your attention the Angle Chasers playbook, which I've placed over here on the right side. This is a collection of 4 different strategies that are going to help us chase down missing angle measures or variables in these types of problems. Now, I've warmed up, I've stretched out my legs, I'm ready to chase. Let's start with example 3E over here on the left side. I'm taking a look at the figure and I'm telling myself, where are my clues? I notice that I'm trying to eventually get over to solve for this variable of x. However, I have a few more clues over here on the left side. I have an actual measure of this angle right here, 54 degrees, and I also know that that's sitting inside of an isosceles triangle because I've got two sides that are congruent. What that means is I could go over here and take a look and remember play number 1 in our playbook. When you have an isosceles triangle, the angles that are opposite those congruent sides are also congruent to each other. So that means in this example, angle A would be congruent to angle B. So now back to the example we're working on, what that means is that this angle here and this angle here are congruent in size. So I can use this 54 to my advantage. I know that there's 180 degrees in every triangle. So if I subtract the 54 degrees that have already been used, that means that there are 126 degrees remaining. Now, those 126 degrees need to be split evenly into these two base angles. So if I take that 126 and divide it by 2, that means that each of those base angles are 63 degrees in size. Now I know what you're saying. Hey, you still haven't found that x over there. Yeah, I know. Be patient. We're going to get there. So that means that this angle right here is 63 degrees, this one right here, 63 degrees. Okay, so now my attention is right here. If I have this 63, I know that this angle right here is involved in a linear pair with that 63 degree angle. So that brings me over here to play number 3. When you have a linear pair, that means that it's two angles together that create a 180 degree straight line. So if I take that 180 degree straight line and subtract the 63 that have already been used, that means that there are 117 degrees remaining for this angle right there. Okay, now you're still saying, hey, I've got to get over to that x. I know, we're close. So now what we can do is focus in on this triangle on the right. This triangle appears to also be an isosceles triangle because of that marking and this marking here. That means it has two sides that are congruent. That actually means that this angle of x and this angle over here are the same size. So I could also refer to this one as x. So, how can we handle this? We've got a couple options. What you could do is, if you're a formula type of person, is you could tell yourself that x plus the 117 degrees, those three angles together all equal 180. And now you just kind of have an algebraic equation that you can solve. You've got some like terms here that could combine to make 2x plus 117 degrees is equal to 180. And now you're just 2 steps away. We're going to subtract the 117 from both sides, making sure that we keep our equation balanced. That'll scratch out. And you're left with 2 times this thing called x that we're trying to find out is equal to 63 degrees. And now in this final step, you could simply divide by 2, scratch, scratch. That x must be representing 31.5 degrees. And we're going to go ahead and box that up nicely so that our teacher can find it. Okay, let's go on to example 3F. I'm going to go ahead and switch colors so that we can distinguish from one problem to the next. Let's go ahead and grab a little bit of blue action, and we're ready to go. So in example 3F over here, we have a good amount of clues. It's just one triangle. It appears to be an isosceles triangle since those markings are in the picture. And we have either an expression or a value for each of the 3 angles. So the only wrong move that I could make here is somehow try to connect this 5x with this 3y right away, since they're different variables. So I'm going to bring my focus back to these two. Since this is also an isosceles triangle, that means that this angle and this angle are equal in size. So I can instantly set up an equation that says that that 75 is equal to that expression of 5x. This is now just a simple one-step equation. You're going to divide both sides by 5, scratch, scratch, and that x must be equal to 15. All right, halfway there. So now the only thing we have to deal with is finding this y. So I'm just going to go ahead and write in the new information that I found. I knew that this was 75 degrees. And now I can rely on strategy number 4 from our playbook, which is if you know the measure of 2 angles in a triangle, you can always find the third. So I'm going to use the fact that I know 2. So I'm going to take that 75 and add the other angle of 75 and learn that those two together make 150. Now the strategy here is that if I remove that 150, so again, remove 150 from a full triangle of 180, that means that there are 30 degrees left over. So that means that this angle right here has a measure of 30 degrees. So I now have the measure, and I also have an expression, which means that I can set those two things equal to each other. So that 30 degrees is currently being represented by the expression of 3 times y. Now we're one step away. We can simply divide by 3, scratch, scratch, and that means that that value of y must be equal to 10. Boom! Feeling good about it. We're going to box it up, and we're ready for the next challenge.